So children, we are back again with physics, class 9 physics motion part 3. Okay, last day we had got an idea about, till now we had got an idea about motion. What are the different types of motion? Okay, then what is scalar quantity, what is vector quantity, what are the different types of motion, uniform motion and non-uniform motion, what is distance, what is displacement, and then we have also come to know about speed and velocity. Right, now today we are going to learn about acceleration and graphical representation of motion. Okay, now from the suppose I am giving you one real life situation. Suppose you're riding one cycle, okay, and you started from your home riding the cycle, okay. You're going to go to school, okay, and in the way you got one bumper, okay, and you applied brake, okay, and you did not come to an rest, but your speed slowed down, okay. Now you're moving to the school, okay, towards the school, okay, and again you geared up your speed and you went to your school, okay. Now in this case what happens, once you started from rest but you picked up a speed, okay, as this is having a direction, so I'll call it as velocity, okay. You picked up a velocity and as you moved forward but you changed your speed, okay. Why did you change? Because you got a resistance, okay, and as you got a resistance you slowed your speed, and then again after overcoming that resistance you again geared up your speed, okay. So what happened is the velocity of your cycle, once that uniformity is destroyed, okay. So when in this situation we call it as acceleration. Now what is acceleration? Okay, acceleration is the term that defines the rate of change of speed, okay, or rate of change of velocity actually, okay. Now what is acceleration then? What did I tell? Rate of change of velocity. Rate of change of velocity, okay. So if it is rate of change of velocity, what is velocity? Velocity is distance by time, correct? Then this is change of velocity also. So when I talk about a change, there will be difference in velocity. So if I take initial velocity as u, initial velocity of any moving object as u, and final velocity of the moving object as v, then and time, let the time be t, okay. Then how do I express this acceleration? I can express acceleration, if a denotes acceleration, then I may say final velocity minus initial velocity by time. This is the formula for finding acceleration. And see, as you know, velocity is what? SI unit of velocity is meter per second, okay, and here we have time as the denominator. So what it will be? of SI unit of acceleration, it will be meter per second square. Understood? So acceleration means what? Acceleration means rate of change of motion, rate of change of velocity per unit time. Okay, and when do we get like this kind of situation? When suddenly we change the speed of suppose we are or I mean say like you're moving in a highway, okay, with a particular speed, and suddenly you found the road as empty, okay, no one is there. So what will you do? You will gear up your speed. So in that case also you're increasing, you're accelerating the body. Okay, so acceleration means initial final velocity minus initial velocity by time. So let's define it. Okay, so here we have definition of acceleration, that is frequency at which velocity changes. Okay, that means the number of time velocity changes, that frequency per unit time is known as acceleration. Okay, next definition is rate of change of velocity per unit time, again, which means change in velocity by time is acceleration. Next, acceleration is denoted by the letter A, initial velocity is denoted by U, and final velocity is denoted by V. Now what is initial velocity? Initial velocity is the velocity at with which you start the motion. If you are starting from rest, then your initial velocity will be 0, and if you are starting from motion, like you were in motion only and you suddenly geared up your motion or you slowed down, so in that case that will be your initial the speed with which you were moving, that will be your initial motion. But in case of rest, initial velocity will be 0. Understood? Okay, next one is final velocity. Final velocity is the velocity which you have attained after by gearing up your motion. Okay, that is your final velocity. And how do you obtain acceleration? You can obtain acceleration by final velocity minus initial velocity by time. Okay, in case you're starting from rest, your initial velocity will be 0 and final velocity it will be there, then it's okay, you will get positive acceleration. But in case if you were in a certain speed and you slowed down, then at that time your velocity will decrease, your final velocity, your initial velocity will be more than the final velocity. In that case you will have negative acceleration, okay, because you have decreased your speed. Okay, next is, it is a vector quantity. Why vector quantity? Because you know that acceleration is velocity by time, and velocity, you know, it's already vector, it will always have a direction. So as acceleration, acceleration's rate of change of velocity, which means it will obviously have a direction, so it's a vector quantity. Next, the SI unit of acceleration is meter per second square, or you may also denote it by meter second minus 2. Okay. Now let's see by solving one problem. Okay, what is acceleration? Now suppose you have started your motion from your home, okay, and you are riding one cycle and you have been moving forward towards your school with a velocity of 6 meter per second, okay, and suddenly you got a bumper, okay, and this 6 meter per second you are moving, suppose for 30 seconds you are moving with this velocity only, okay, and suddenly you got one bumper and you slowed down your speed, okay, and your now speed comes to, let it be 4 meter per second. Okay, and with this speed only you are moving for 50 seconds. Okay, you have got two situations. Okay, now let us calculate the acceleration of yours. Okay, now you see there are two accelerations that can be calculated from this problem. One is if you are starting from rest and you attain one motion. Okay, so from rest means what? Your initial velocity is 0. Okay, initially rest means there was no motion, that means initial velocity was 0. And what was your velocity when you geared up? Okay, that was 6 meter per second. And for how long did you continue to move with 6 meter per second? For 30 seconds. Correct? So what will your acceleration be? In this case, your acceleration will be final velocity minus initial velocity by time, which means 6 minus 0 by 30. Correct? So it will be 6 by 30, which means 1 by 5, or we can say it is 0.2 meter per second square. Right? So this is your acceleration. Till here your acceleration is 0.2 meter per second square. Now in the second case, okay, what is your initial velocity? Here your initial velocity will be 6 meter per second only, because this part you have already covered. Okay, now when you are calculating the next part acceleration, okay, which you have slowed down, okay, so which means your initial velocity was 6 meter per second. And what is your final velocity? Till how much we were talking about? For 50 seconds you were moving with 4 meter per second. Correct? And time was for 50 seconds. Right? So in this case your acceleration will be again final velocity minus initial velocity by time, which means final velocity is 4 minus 6 by 50. Now 4 minus 6 means what? It will be minus 2. Minus 2 by 50. Correct? Which means minus 1 by 10 meter per second square. Right? Which means minus 0.1 meter per second square. So initially your acceleration was positive, okay, and now you have attained one negative acceleration, which means you have decreased your speed. Understood? Okay, now we will be talking about two types of acceleration. One is uniform acceleration, okay, and non-uniform acceleration. Now what is uniform and non-uniform acceleration? Now uniform acceleration means if the change of velocity is, change of the magnitude of the velocity is equal in equal interval of time. So it is magnitude of velocity is equal. Okay, magnitude of change of velocity is equal in equal interval of time. Okay, and for non-uniform acceleration, what is it? For non-uniform, the magnitude of change in velocity is not equal. I mean, suppose a car is moving in moving and it is going on dropping some students in the car, or your friend and you all are riding in one car, and suppose whenever your friend's house come, one of your friend is getting down from the car, and so it is increasing after every 5 minutes. It is happening. So in that case it will be uniform acceleration. And when is the case of non-uniform acceleration? When a car is moving in a crowded road. Okay, suppose it is moving for 5 minutes, it's moving with one speed. Okay, again for the next 5 minutes it's changing its speed again. Okay, so in a crowded road, once it is increasing the speed, once it is decreasing the speed. So in that case the change of velocity is unequal. Okay, but time interval is equal. Okay, so this is the case of uniform acceleration and non-uniform acceleration, and in both the cases, as this is acceleration, so its SI unit is again meter per second square. There is no change in that. Okay, next, now I'll give you another situation where you are standing on the rooftop. Okay, and you are dropping one ball, okay, from the top of the roof, and it is coming down. Okay, now you all know that Earth has got a gravitational pull, right? And with the gravitational pull, any object any object, it exerts and force on any object on the Earth. Okay, and so when that body is coming down, that gravitational force will also come into account. So there will be a change in velocity. Okay, there will be a change in velocity, which means there will be acceleration, and acceleration due to this is known as acceleration due to gravity. And this is a situation when a body is falling from a certain height, okay, its velocity will increase, okay, in equal interval of time. Okay, so this is known as acceleration due to gravity, and its value of acceleration due to gravity is 9.8 meter per second square. Okay, also suppose you are standing and you are throwing a ball up. Okay, you are throwing a ball up. Okay, then what will happen at a certain level? Okay, at a certain level the body will have a constant acceleration but will have zero velocity, because at a certain level it will come to stationary. Okay, so that time, as it is Earth is having a gravitational pull, okay, due to the gravitational pull, okay, or acceleration due to gravity, okay, the velocity is coming to 0. Okay, the velocity will come at 0 at a certain point. Okay, it will go up and then it will come down, but in that case velocity will be 0, but it will have an acceleration. So this is a special case in which when a body is thrown up, okay, velocity comes to 0 at a certain point. When it reaches its highest point, okay, velocity comes to 0, but there will be acceleration to it, because there is gravity will pull it down. Okay, force will be exerted on it. As a result, this is a case where there will be acceleration in the body, but velocity will be 0. Next, there is another situation when an object is moving with uniform speed. Okay, object is moving in a certain direction. Okay, and there will be acceleration perpendicular to the direction. When a body is moving in a horizontal road, and acceleration due to gravity, okay, we can say that acceleration is perpendicular to the direction of motion. Correct? Acceleration perpendicular to the direction of motion. And when is this case? When a body is moving in an horizontal road. And what type of acceleration is acting on it? It is acceleration due to gravity. Okay, these are the special cases. Okay, next we have graphical representation of motion. Okay, so long we have studied about distance, time, velocity. Now we will see what is a graphical representation of it. Okay, so there are two types of graph that we will be dealing with. One is distance time graph and velocity time graph. Distance time graph and velocity time graph, by it we mean that along the two axes, okay, when we draw a graph, okay, along its two axes, one will be time, and for a distance time graph, the y-axis will stand for the distance. Okay. Now, if we find a graph in which if the change in position of the object is uniform with time, we get this type of graph, and this is known as uniform body is moving with uniform speed, or this graph denotes uniform speed. And if you want to find the velocity, okay, we can determine from the slope of the graph. Okay, what is slope of the graph? Change in time, change in distance by change in time. Okay, so suppose this is S2 distance and this is S1 distance, and this is suppose T1 and this is suppose T2. Then slope of the graph will give the velocity, which means it will be S2 minus S1 by T2 minus T1. So slope of the graph gives the velocity. Okay. Next we have graphical representation of non-uniform speed. In this you will see that the graph will have this graph, if we plot this side distance and here if we plot time, then we can see that there is no uniformity in the graph. Okay, sometimes it's increasing, sometimes decreasing, so there's no uniformity in the graph. So this is known as distance time graph, which is for non-uniform motion. Or non-uniform speed or velocity. Okay. Now let's describe velocity time graph. In velocity time graph, instead of distance and time, we will have velocity in one axis and time in the other axis. Okay. Now there are two types of velocity. One is uniform velocity and non-uniform velocity, correct? So at each case we can plot the we can find the distance also. Okay, for a uniform velocity means there will be no change in the magnitude of the velocity, so it will be a straight line, but time will change. Okay, so it will be a straight line. Now suppose this is V1, okay, and suppose this is T1, this is T2. Okay, now if I tell you to find distance, we all know that distance is speed into time, correct? From the diagram or from the graph we can find the speed, distance. Okay, what will be distance? Distance will be if T1 and T2 are the 2 points, and this is, suppose if I give a name to the points A, B, C and D. Okay, then the area covered by ABCD will give the area covered by the point ABCD will give the distance. Okay, so distance will be, if S is denoted by the distance, so we can say AB into BC. Okay, as you know, you can see from here it's a rectangle, okay, and it is length into breadth. So that formula if we apply, we will get the whatever is the value of T1, whatever is the value of T2, and from here if we can easily get AB's value and AD or BC's value, correct? So from the magnitude of each we can find the distance covered by by this velocity. Okay, and this type of graph is for uniform velocity. This is for uniform velocity. But what about if there is in equal interval of time there is change in velocity? Then if this is the velocity and this denotes the time, then rate of change of velocity, okay, rate of change of velocity, which means acceleration. So this type of graph denotes uniform acceleration. Uniform acceleration. So this type of graph denotes uniform acceleration. And at any point, if you want to find out the distance covered by the body, again we will be finding out the area covered by the graph. Okay, suppose this is V1 and this is suppose V2, then and this is T1 and T2, then we can see this is one area of a triangle and area of a rectangle or square, as the case may be. Okay, and finding the area of this point, let the point be A, B, C, D. And what is distance then? Area A, B, C, D. Understood? This is the case of uniform acceleration. Okay. And what is the case of non-uniform acceleration? That means velocity will change at velocity changes at anyhow. Okay, so in this case, this is the case for non-uniform acceleration. There is no uniformity in the magnitude of velocity. Okay. So that's all for today's lecture video. Okay, at the end of the video, I have 3 questions for you. First is define acceleration. Second is give an example of uniform and non-uniform acceleration. Third is a sum, that is you are riding a cycle with a speed of 4 meter per second, and suddenly you geared up your speed to 10 meter per second for 3 seconds. Okay, and then you lowered the speed to 5 meter per second and continued for 5 seconds. Find the acceleration. Okay, that means you were at a certain speed, and you suddenly increased your speed, and that was for 3 seconds, and then you lowered your speed to 5 meter per second and continued that for 5 seconds. So there will be 2 cases of acceleration. I need both the values of acceleration, and here is the example of uniform and non-uniform acceleration. You have to give, if you have understood what is uniform and non-uniform acceleration, I hope you will be able to give. So that's all we have for today's video. See you in the next video.